This is still under adding and subtracting polynomials, and this is the application part of it. So it says find the area of the shaded region if all of that is the area of the total region, and that is the area of the unshaded. So you're going to do total minus unshaded. So you're going to do the whole thing, and you're going to pluck out that piece. And so the total is 9x squared minus 6xy plus 3y squared. You're going to subtract, so I'm going to put them underneath who they go underneath and subtract it, and I do it vertical. So it's minus 3x squared and minus y squared gives me 6x squared minus 6xy minus 2y squared, and that is the area of the unshaded region. And when you combine like terms, you don't have to match up every single one of them. Find the total area of the figure. I have 1y squared, 2y squared, 3, 4y squared. I'm going to put it right there. Total, so it's 13x squared plus 13x squared plus xy plus 5y squared, and that's my total answer. Find the area of the shaded region if the area of the total region is that. So again, we're going to do total minus unshaded to give shaded. Unshaded equals shaded. So I have 5x squared minus 4xy plus 2 for total. I'm going to subtract these. I'm going to put them underneath who they go and change the sign. Minus x squared, pluck that out, minus xy. And so the total, or the shaded region, is 4x squared minus 5xy plus 2. When you write these, make sure your exponents look like exponents. Okay? The other thing is alphabetical order from highest exponent to lowest. And so it went 4x squared, and then it went x to the first, and the y came in, and then this has x to the 0, which is 1, so that was next. That is 11-1, adding polynomials.